Hello guys, so today we are going to discuss the problem largest family on CodeChef. So the problem statement goes like a certain parallel universe has exactly n people living in it. The ith of these n people claims that they are the parent of exactly ai of these n people. However, some of these people might be lying. The ith person may either tell the truth, in which case that they have to include exactly ai children, or lying, in which case they can have any number of children. Okay. So it is known that each person has at most one parent. Further, as one would expect, it is not allowed for a person's child to also be his ancestor. What is the maximum possible number of truth tellers in the universe? The first line of input will contain a single integer t denoting the number of test cases. Each test case consists of two lines of input. The first line of each test case contains a single integer n, that is the number of people, and the second line will contain the claims that they are making. Okay, that will be an array. So we have to return for each input a single line that will contain the maximum number of people that can be telling the truth. So these are the sample test cases given to us. So let us first copy them and have a closer look. How can we take this forward? Okay. So these are the test cases given to us. So now let us first separate these test cases. So these are the four test cases that are given to us. Okay. So according to the problem, this is the number of people that we have. For example, this is the third test case. Okay. Here number of people are 3. Here number of people are 3, and the first person is claiming he has 2 children, second person is claiming he has 0 children, and third person is claiming he has 1 children. Okay, and we have to output the maximum number of truth tellers that we can have. Okay, so in this problem we have to cater to two things. So these two things would be, first of all, we have to find a particular order in which we will cater to the claims made by the people. Okay, so this is a random order that is given to us, but it is on us in which order we want to cater to the claims that are made by the people. Okay, second point would be how we will verify that a particular person is telling truth or not. So these are the two things that we have to first of all focus on. If we like come to the first point, where we have to find a particular order in which we will cater to the claims made by the people. Okay, so suppose we have two people. One is claiming that he is having 1 children, and second is claiming he has 4 children. Okay, should be the order in which we would cater to these requests. Okay, so since the first person is claiming he is a parent of only 1 children, okay, and the second person is claiming he is a parent of 4 children. Okay, if we include this one, then the number of children remaining would decrease by a factor of 4. Okay, but over here it would decrease by a factor of 1 only. Okay, and since we have only limited number of people where we can assign them as children, okay, so we have only limited number of people n, it would be like feasible to pick the smaller number over here first. Okay, so if we pick the smaller number over here, that is a greedy approach that we are following. Okay, so that would benefit us in the longer run, because we are just narrowing down our search space little by little. Okay, instead of drastically decreasing our search space. Okay, because picking the lower number does not decrease our search space drastically. So first point is clear to us that we will pick the smaller numbers first. Okay, so what we can do is we can sort these array that are given to us in increasing order. Okay, so suppose if the array given to us is 2 3 1 2, we will cater to the request in this order, that is 1 2 2 and 3. Okay, now second point is how we will verify that a particular person is telling the truth or not. So if a particular person is claiming he is a parent of X children, okay, so let's suppose we draw a family tree as well. So the tree would look somewhat like this. Okay, now if this claims that he's a parent of X children, okay, so sum of all the person over here that are the nodes over here would be X. Okay, and we cannot include these people again and again, okay, because it is given to us that each and every person has at most one parent, and further, as one would expect, it is not allowed for a person child to be also his ancestor. Okay, so if a person is picked as a children of any of the person, then he cannot be picked as a children of any other person in future. Okay, so if we pick these three numbers, let's suppose, or these three nodes as children of P1 or person 1, then we cannot pick this person again and again. Okay, so the search space, initially our search space was n. Let's suppose we have n people. Okay, now in the family tree, the family tree would be somewhat like this. It would have at least one person at the topmost level. It would have at least one person at the topmost level. Okay, now people over here can be two as well, but here it would be at least one. Okay, and here the person at the topmost level would not be children of any of the people over here. Okay, because he is the starting ancestor. Okay, so our search space becomes n minus 1. So for any given family tree, there would be at most n minus 1 children. Okay, this is our search space for children. We cannot have number of children greater than n minus 1, and you can draw any of the family graph and you can like check it also. So what if we include, or if we say that we are like rectifying, or we are considering the claim made by the person P1 as truth, if we consider that as truth, okay, so our search space would then become n minus 1 minus x. Okay, why? Because all the children that we have included, we cannot include this in future, but the parent can be a son to any of the people that would occur in future. Okay, so we would exclude all these x people. So a search space would be, suppose initially it was s, so it would become s minus x. Okay, so what we can consequently do is we can keep a count of some children's included or child included. So whenever the child included, we have to see. So whenever we come to a particular person and we consider that person claim to be truth, we will increase our child included by the number of children of that particular person. Okay, so that would be like child included equals to child included plus a of I, and we can go up till this is less than equals to n minus 1. That is the maximum children that we have over here. Okay, so just to summarize all the points, what we will do is we would do a dry run as well over here. Okay, so I'll quickly erase all of these and we will stick to the 2 points that we have already discussed. That is the first point we were to find out, that is we have to find a particular order in which we will cater to the claims made by the people, and how we will verify that a particular person is telling truth or not. Okay, so if we have to summarize this, for this we are sorting the array in increasing order, and for this we are keeping a child included or children included, child included, okay, and that would be less than equals to n minus 1, or you can express this as less than n as well. Okay, so let us pick this test case, that is the third test case, just to do a trial and on an approach. So initially we have three people over here and the array given to us is 2 0 1. So in first step we will obviously sort the array in increasing order. Okay, so first person says that he is a child of 0 people. Okay, so initially a child included was 0, child included was 0. Now in this iteration if we include this as well, so it would not affect our children included, so it will still remain 0. Okay, but our answer or the included people that are telling the truth, that will become 1. Okay, so now let us move to the second claim. So now this is claiming that he is a parent of one child. Okay, so children included would become 1, and by increasing the children by 1 or children included by 1, that is not surpassing the limit, that is n minus 1. N minus 1 would be 2 over here. Okay, so adding 1 is not surpassing 2, so obviously we can include this, so included would become 2, and we can see this as this. Suppose a p1, a person p1 is a parent of person p2. Okay, now this is also done. Coming to the third claim, he is claiming that he has 2 children. Okay, now if we include this, our number of included children would become 3, but that would surpass the limit. Our limit was 2, so this is like greater than 2. Okay, so obviously we cannot include this, so our answer would be 2 only for the third test case, that is the maximum number of people that we can include, or the maximum number of truth tellers that we can include is 2. Okay, and from, so I hope the problem approach was clear to you guys. So I want to introduce you guys to another new feature that we have brought in at CodeChef. So what you guys can do is you can go on to any of the practice problem in the CodeChef tab. Okay, and if you're stuck at any of the problems or you have any doubts regarding a certain problem, you can go to ask a doubt over here. You can click on the pop-up that is given, and you can chat with designated mentors that are over there, and there would be people to help you out with any of the doubts you have for a particular problem. Okay, so let us look at the code solution as well for the approach that we have already discussed. So initially what we are doing is we are taking the number of test cases as input, and for each and every test case what we are doing is we are taking the input for the number of claims that are being made, or that is equals to the number of people. Okay, and then what we are doing is we are inputting each and every claim for that particular person, that is each and every person will come and he will make a claim for number of children he is having. Okay, and then we are sorting them. Okay, now why we are sorting them, that we have already discussed. Okay, because of the point 1, because we have a particular order in which we will cater these claims made by the people, that we have already decided that we will be sorting in ascending order only. Okay, and in second point or the second half of the code, what we are doing is we are taking 2 variables, that is included count, that is the total number of claims that are true as of now, that would be 0 to begin with, and total number of included sons. Okay, so that is the search space of the sons that we have already included, and this would not be greater than equals to n. Okay, this also we have already discussed, that is included child count would be less than equals to n minus 1. Okay, so what we are doing is we are iterating throughout the list, that is a sorted list that is consisting of that is consisting of all the claims that are being made, and we are just checking if by including a particular claim, that is each and every person will come and is making a claim I, and these are in ascending order as of now, since we have already sorted that array. Okay, and we are seeing if sons included plus claim of I doesn't break our limit. So our limit is sons included is less than n, okay, or less than equals to n minus 1. So what we do, if it doesn't break our limit, we include this in our sons included. That is the total number of count uh, of sons that have been included as of now. That would be previous number of sons that would have been included plus the particular claim that we are catering to. Okay, and if the claim was true, we will also increase our included count, and at the end we'll just print out our included count. Okay, so let us run this on the sample test cases as well. For the sample test cases, we are expecting the answer as 2122. Okay, and we do get the answer 2122. So let us submit this for all the test cases that are given and see if it passes all the test cases or not. It does pass all the test cases. Okay, so our approach was correct for the particular problem. So we'll see in the next problem. Till then, keep coding and have a great time, guys. Thank you.